continuing my notes on Pascal's triangle and the binomial theorem. I'm going to continue problem 2. I used the numbers from Pascal's triangle. I started with x and put x to the 4th power, went in descending order because it was on the left here. Now I'll start on the right and I'll use 3, positive 3. And I'll start with an exponent of 4 on the right hand side. So 3 to the 4th, 3 to the 3rd, 3 to the 2nd, 3 to the 1st, 3 to the 0. Now I'm going to go through and do that multiplication that I have here. I'm going to raise the powers here. So 1 times x to the 4th, 3 to the 0 power, anything to the 0 power is 1. 4 times x cubed, 3 to the 1st power is 3. Then 6 times x squared, 3 to the 2nd power is 9. Then 4 times x to the 1st times 27 plus 1 times x to the 0 power is 1 times 81. And then go through and multiply those. 1 times x to the 4th times 1 is x to the 4th. 4 times x cubed times 3 is 12x cubed. 6 times x squared times 9 is 54x squared. 4 times x times 27, I think that is 108x. And then 1 times 81 is just 81. So there is the expansion of x plus 3 to the 4th power. Again, this can be done another way. If you're taking a standardized test and you need something that's quick and fairly painless with making little silly mistakes, then this would be a perfect way to do this. Okay, now I want to expand 2x minus 3 to the 3rd power. I'm going to do it the same way. I'm going to add 1. Hopefully you notice as I put 4 blanks, 1, 2, 3, 4. Hopefully you notice that this is a little bit different for 2 reasons. Number 1, I've got x to the 1st power here, and here I have a variable. Second reason, I have a positive 2 and a positive 3. This is now negative. So there's a couple little things that you do here that makes it different, but not too different. Okay, so I'm going to get my Pascal's triangle. I need the row that has 4 terms in it. 1, 3, 3, 1 is my row. So 1 times 3 times 3 times 1. That's my row I need. And then I need to, try to see if that would help. I put my flashlight up there for us. Okay, now I'm going to put 2 x to the 3rd. So as you can see, I'm actually raising both of those to that power. 2x to the 3rd, the 2nd, 1st, and 0 power. Okay, and then I'm going to start on the right-hand side, and I'm going to put negative 3. So I'm going to put negative 3. Notice I put parentheses around it because it does make a difference. To the 3rd power times negative 3 to the 2nd power times negative 3 to the 1st power times negative 3 to the 0 power. And now I'm going to do the exponents here. I have 1 times 2 cubed is 8 x cubed. And then negative 3 to the 0 power is still positive 1. Then I have 3. 2x times 2x is 4x squared times negative 3 to the first power is negative 3. Then I have 3 times 2x times 9. And I have 1 times negative 27. Okay, now let's multiply. 1 times 8x cubed times 1 is 8x cubed. Negative 9 times 4x squared, negative 36x squared. 6x times 9 is 54x. And 1 times negative 27 is minus 27. Okay, let's look at the next one. I have 5 plus 1, so I need 6 blanks. I will go up here and draw myself 6 blanks. So let me do that. 1, 2, 3, 4. Gonna run out of room. 5, 6. So I squeezed them in there. Then I'm going to put, is it this row? 1, 2, 3, 4, 5, 6. So 1, 5, 10, 10, 5, 1 in the blanks. 1, 5, 10, 10, 5, and 1. I'll put 3x to the 5th, 3x to the 4th, 3x to the 3rd, 3x to the 2nd, 3x to the 1st, and 3x to the 0. And then I'll go put positive 5, 5 to the 5th. I'm going to have to grab me a calculator for this one. 5 to the 4th. Not everybody can do all the math in their head. Well, there may be somebody out there watching that can. I envy you. I can do most math in my head, but not all of it. Of course, I could do it in my head, but to do it accurately every single time, I can't do it all the time, as you can see if you've watched my videos. Now I'm going to do my exponents next. 1 times, let's see, 3 to the 5th power. 3 to the 4th power is 81, so is that 243? X to the 5th times 1 plus 5 times 81 x to the 4th times 5 plus 10 times 27x to the 3rd times 25 plus 10 times 9x squared times 125 plus 5 times, okay, so 5 times 3x to the 1st power is 3x times 5 to the 4th power. 5, I think that's 625. And then 1 plus 1 times 3x to 0 is 1 times 5 to the 5th power. Is that 3,625? Let's see. 625 times 5. Oh, 3,125. Let me make sure. You can also do that quickly with 5 raised to the 5th power. And 3,125. Okay, next I'm going to multiply 1 times 243x to the 5th times 1, 243x to the 5th, plus 25 times 81x to the 4th here. So 25 times 81, 2,025. X to the 4th plus then 10 times 25 is 250 times 27. So 250 times 27 is 6,750. X to the third plus 90 times 125. Oh, I don't think I did that right. 90 times 125. 11,250. X to the third plus, that was this one, 625 times 15. 9,375. Oh, this is x to the second. See, I caught my mistake. I think I got distracted. Plus 1 times 1 times 3,125. So that would be 3,125. Okay, so that's my answer to number 4. Now, the last two examples I want to do are on a different page. They are on page 49 in our notebook. And if this is a different year, then it's going to be on page 85 in our student journal. I want to finish, it's page 49 for this school year, 2020. I want to finish number 10 and number 11. So what I'd like for you to do, I want you to do these two problems, stop the video, and then come back and check your answers. I'll do them as well right now. Here's the answer to number 10. Here's the work that I did to come up with this answer. And then the answer to number 11 is here. So here's the work that I did, the multiplying that I did, and then the final answer. So hopefully now you can expand any binomial that you're given to find what would have been the product of 5 binomials here, 4 binomials here.